Hey, what's going on, guys? Xiangqi here. In this video we're gonna be creating a core function of whatever chess engine, no matter which variant that is, and the function is called generate moves. So I've already prepared that function, so in order to avoid you watching me typing that forever, and also in order to make sure that typos are not gonna be causing any nasty bugs, I would be pasting the parts of the move generator, then testing that manually, talking through the code, and that's the way to go basically. And also I've created some additional data structures to have a look at. So without further ado, let's actually start. And again, like, this is the most amazing and exciting part of writing a chess engine for me personally, so I hope this would be as interesting as it is to me, to you guys as well. So just to give you an idea, so the overall generate move function is this. So this is the overall amount of code. It could be more optimized based on speed, based on code size, but I tried to keep a didactic approach. So anyway, so probably, yeah, let's start with this guys. So we start with this new extra definitions, and just, okay, so somewhere here, I guess. So what we have here, so first of all, we want to define piece types. These are just the random numbers. Well, not the random. Well, I mean, like, I just started to go next from the offboard. So the idea is it would be extremely useful and kind of like nice to distinguish between piece types within the move generator. Hold on a sec, I just thought, is that also applicable to a square attack? Yeah, that also can be applied to a square attack, but yeah, for some reason, yeah, obviously I didn't yet change that. Or no, hold on a sec, it's attacked by either red. No, hold on a sec, just hold on a sec, guys. Okay, sorry, so no, here we're just looking for specific pieces, so it's not an option. Yeah. So okay, I will now keep on explaining through this code. So just to run the code, so you see this source. If you just download it from GitHub, from the link below in the description below this video. So engine is the file we're working with, GUI cnc.html. You just run this and open the browser console tools, developer tools. So here you'll see the output. Okay, so we have these piece types, so starting from 16 and up to 22. So the numbers doesn't matter themselves. The matter of this constants is just to distinguish between the piece types. So let's say for move generator, when we would be generating moves for pawns, we need to know what type of piece is that, whether that is a pawn. And then also when it comes to capturing pieces, we want to know which color the target piece is, and that's the reason for distinguishing the colors. Now we have a couple of arrays to map these sort of values. So piece types, we have, so you remember the structure. So it's kind of red pawn, red advisor, red bishop, and so on. And here we have black pawn, black advisor, black bishop, black knight, and so on. So we just map the types to pieces, to actual piece codes. Okay, so here are the piece codes, and here we map them. So let's say we would be indexing the piece type array by a certain piece. Let's say that would be red bishop. It would return us the type of bishop. Or let's say we would be indexing the piece type by the black bishop. It would give us bishop type exactly the same. So here we want to map piece to type, hold on a sec, map type to piece. Okay, also we want to use another constant for color, which I call no color, which is just a hack to for this piece colors, because if we will map offboard square, if we will map empty square to piece colors, it should, and if that would be equal to 0, it might be considered as white. And just to avoid those possible complications and bugs, we better just call it no color, and this is 2. So this is definitely, so whatever piece, the piece, let's say again, like white pawn, it would return red. Let's say black rook, it would return black. But empty square would return no color. So this would never ever be equal to side to move or to the side opposite to the side to move. So just a little hack. And here we want to map color to piece. So again, we can like extracting the color from the piece code, and the way how we do this, just using the piece code as an index to index piece color array. And that's the way how we can say whether the piece is black or red or black. Okay, so we're done with this stuff, and now we can already go for the section of the code responsible for generating moves. Yeah, before that, we will also need this code that I've commented out in the previous part. This should be called bishop move offsets. I'm no longer using these guys as well. And so here I say offsets to get target move, to get target squares for knights. Here we have the offsets to get target squares for bishops. Okay. Print board to console. Oh, so this was just the print attack. So we no longer need this print attack. Okay, so just to clean up things a little bit, don't need that anymore. So here we have our square attack function. And just right below this, we define our move generator. Okay, so there would be a few functions here, but we start with the generate moves. So let's say generate, this is called a pseudo legal move generator, so it would be generating all the legal moves, but not taking into account whether the king has been exposed into a check or not, because this sort of a feature would be left for the make move function, the traditional way how I always do with my chess engines. So generate pseudo legal moves. Just hold on a sec. I want to make sure that I spell this word correctly without any mistakes or typos. Pseudo, yeah, seems to be well. Okay, and here we just create our function called generate moves, and here we go. So well, I could have typed it, but yeah, it's just no, let's go this way. So I just type a few lines of code, and then would be pasted in the blocks, so that would be easier to consider. Okay, and also before that, I just want, yeah, the empty board is just fine. This is fine, so I don't want to print attacks. And here I just want to call my generate moves. And yeah, so let's say, console.log gen moves, just to make sure generate moves. Okay, so we are within the generate moves function territory. So the very first thing to consider, we need to loop over all the moves on the board. Well, obviously, some sort of an optimization is to use the piece list, but that's a little bit too complicated, and we'll start with the simplest possible way of generating moves. It might be a little bit slower, but quite pretty easy to debug and should be stable eventually. So first thing to do, we need to loop over all the board squares, quite pretty simple. So I say let source square equals to 0. Just hold on a second. I just want to recall my memory. How did I implement? Yeah, and the length of the board. Yeah, so equals to 0. Source square is less than the length of our CNC board, and source square plus plus. So now it should be okay. So yeah, the next condition is we need to make sure that the square is on the chessboard, so it's not off board. Save, and just to give you an idea, so say console.log, and here the source square, and just run the stuff. It should print all the squares, but obviously this kind of numbers don't tell us much, so we can pre-print them using the coordinates like this. Coordinates square like this, and this is it. So we got all the squares we're looping over here. Okay, so probably yeah, I guess I just want to copy this this little helper function that already refactors the code a little bit. I'll first walk through this one because this would be reused within the move generator. So eventually this function would be intended to push move into move list, and I guess I would be passing the move list pointer here as well, but for now it only serves the purpose of printing the generated moves to the console. So we're taking source square, target square, source space, what's located on source square, and target space, what's potentially captured as the arguments. Then here is the condition. So if the target piece, what is located at the board of the target square, is empty, or of the color that is opposite to the current site, so this XOR means the opposite color. So let's say color is red, that is 0. So site XOR 1 will be equal to 1. If the site is equal to 1, then site XOR 1 would be equal back to 0. So that's here is the trick or hack to get the opponent's color. So we're extracting kind of like color from the target piece using this piece color array that I've described before, just like I did that. And that's the way how to easily answer the question whether the target piece is of own color or of opponent's color, opposite color. And then we simply distinguish between the capture. So if target piece is available, that means that we're capturing. So here I just print capture, but later on we will be using the specific flag to distinguish between quiet moves and captures, when we'll be encoding all the source square, the target square, and these pieces into the single integer because that's just faster. So we would be using capture flag instead of the absence of capture flag for quiet moves. And the reason for doing that is because when we would be implementing the so-called quiescent search, serving the purpose of getting rid of the horizon effect during the alpha beta search, just literally to avoid engine giving pieces away because he just captures something and then he thinks like he's already better and that's enough. But no, we need to play through the forcing line of captures and only then evaluate the position. So in order to do this, we need to be able to distinguish between the captures and the casual moves. So that's the reason. Well, obviously we would be cloning our generate moves to generate only captures. So we're probably even well, I'm not really sure regarding the architecture. So definitely not sure at the moment. Maybe we would be using this, or probably just make another one to push capture. And that's it. Yeah, that would be probably slightly a bit faster. So yeah, this one will be called push move, and another function would be like push capture. And we could have distinguished this here, but it would be too long when we generated all moves, not only capture. So extra condition, extra branch is not on the cards. Well, just forget that. That's not important at the moment. So let's move further on. So again, in our case, this function simply serves the purpose of printing the source square and the target square, and also if that is a capture, this is about to be printed as well. Okay, so the next thing to consider, we need to for every single move, so it's if not capture rate, if not upboard, yeah. So for every single move, we need to extract the piece itself. So piece is whatever located at board source square. So piece might be also the empty square. So next thing to consider, we want to make sure that we know the piece type. So we're mapping the piece to the type array. So literally extracting the piece. So this would be either pawn, advisor, rook, bishop, knight, canon, and that's it. And also extracting the color for the so that also would be used. Hold on a second. Do we really need the color? Yeah, the color is also absolutely essential. Yeah, sorry guys, just I feel a little bit overwhelmed here. This is the first mode generator code that I've created on my own, and I have invented all these mappings to get the piece type and piece color. Well, I didn't invent this in general, but for this in particular implementation, I didn't ever done that before in this way. Before I was using the specific bits, so the pieces were encoded using, let's say, the 8th bits to encode the color, and tricks like that, and also piece type to extract the piece type. I was using the first 7 bits as it's done in Micromax by Harp Miller, but that's a little bit too complicated, and I really want piece types to be piece encoding to be like from 1 and up to 14, because that's very handy for MVV, LVA, move ordering, and so on. So we'll come to that later on. So the next thing to consider is absolutely essential. So we need to pick up the piece of the side to move. So we're not going to be generating moves for opponent's pieces, only for our own pieces. So I hope this is clear. So if piece color is equal to side, whatever side is, and side would be changed within the move within the make move function, and take back and forth. Okay, so and now let's go for generating moves for our pawns. So first, I just want to put a couple of pawns on the chessboard and see how this works, and then quickly talk through the code to give you an idea how in particular this is working. So let's have a look. So we already have one pawn. It's a legal position for pawn, but still doesn't really matter. Hold on a sec. Sorry guys, this looks like a little, oh, that's because it's the black pawn, right? And we need the red pawn. Save. So I will show the distinguishing by the colors only once. Pawn move of sets is not defined. Pawn move of sets. pawn attack offsets. Oh yeah, I forgot to paste in pawn move offsets apparently. Base color. Yeah. Copy. So pawn attack, knight move, and here we can have the pawn move. So the difference is here we have, for attacks we have down up, because that's the matter of square to get the pawn, to figure out whether it's attacked by the pawn or not. And here we have this swapped on the contrary. So because the pawn, so this is the square relative and this is the pawn relative, that's the difference. Okay, so board zones. Okay, another important data structure to introduce is the board zones. I will walk through that now as well. So, well, I think we can put board zones here because it's only used within the move generator, right? Okay. Yeah, zones of CNC board. Okay, now we finally got the moves. Okay, guys, so let's just put a pawn on a position that we're more likely to be. But hold on a sec. This is weird. Do you want an F1? It shouldn't be. Hold on a sec. This is not right. E1. Hold on a sec. Okay, guys, just hold on a sec. Okay, I just realized the reason behind this weird behavior. So, oh my god, let me think. Okay, guys, just hold on a sec, a little bit more. Okay, so finally, seems like I've realized. So the reason for why it was generating the moves left and right when it was in the territory of the palace is because I skipped generating left and right pawn moves only in case if we have the board zones indexed by the side and the square, and this is equal to 1. So here are the board zones for whites, here are the board zones for black. So it's already a good idea to walk through this data structure. So this is all we have. So this 1s and 2s is what we have our side, so before the river, and that is the opponent's side. And within our side we distinguish this non-palace and palace zones. So all the 2s is the palace zones. So I just when I put the pawn on the within the palace zone, it was generating moves left and right, which is wrong. But pawns are never going backwards, and they are starting here at the 4th rank. So only going further on. So our pawns would never be here. So that's not a problem. And again, like I could have had an extra condition, so if it equals to 1 then break, and also if it equals to 2, but that extra condition would be slowing down the move generator, and I don't really want that. So trying to make the things as fast as possible. So that's the reason why I don't really want to do that. So because our pawns would never ever find themselves here. That would be the illegal position basically. So yeah, I think that just is gonna be an illegal position. It's like in the Western chess, we can't put the pawns on the 1st rank. So if I'm horribly wrong regarding the rules of CNC, please kindly let me know, guys. So if we can put the pawns below this line, say on this line, in that case, I wouldn't need to change code slightly, but I think that we only can put pawns here on the 4th rank. Okay, so the idea is very simple. So if the pawns are before the river, so river is separating the board into 2 parts. So if we are before the river, then we can only push pawns forwards and also capture with pawns forwards. Otherwise, we can, if we cross the river, pawns also can be pushed left or right. And wherever pawn is pushed, it can also capture opponent's piece and would be blocked by own piece. So now I just want to demonstrate that. Okay, so pawn, yeah, let's put the pawn on d4, save. Okay, so here, no, it's illegal, so let's put it on e4. This position is not possible. Let's put it on e4. Okay, so pawn on e4. So only can be pushed to, oh sorry, not e4, e3. Sorry, e3. That's the initial way. Yeah, 4th rank. Well, rank 3, but it's kind of 1, 2, 3, 4th rank actually. So here the pawn only can be pushed forwards to e4, and from here it can be pushed forwards only to here as well. So can go here, can go here. If here would be some sort of a white piece, so let's put a cannon there. So let's just put board e4 equals to red cannon. Doesn't matter, whatever red piece. I'm just not using the pawn to not print any additional moves. So now we don't have moves for pawns because we just it's blocked. And now if this would be the black cannon, if this would be the, say, black cannon, in this case we have e3 goes to e4, but this is already a capture because we're capturing opponent's piece. Okay, so this is regarding the our side of the river, and now if we do cross the river, well, in that case, let's go, pawn goes to e5, and let's say we have the black cannon on e6, save, update. So in this case we have moves e5 to e6, capturing opponent's piece and going sideways as well. So 1, 2, 3, 4. Oh, hold on a sec. This is also should be possible on d4. Oh, on e4. Sorry, e4, e5. Yeah. Also here. Yeah. Or no. Hold on a sec. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. No, it's sorry. So yeah, actually 5 is 6. We're only starting. So only e5 goes for of the river. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, that's correct. So e5 to e6 captures opponent piece. Also can move sideways. So e5 to d5, e5 to f5. So I hope this is clear. And again, like the logic of not capturing own pieces and capturing opponent's pieces is all the same for all the pieces. That's why we've separated this code to push move into movelets, which for now only prints the coordinates. So I hope this is clear regarding the pawns, and we will now move further on. Okay, just sorry guys, I feel a little bit confused by the structure. So hold on a sec. Just can't understand. Okay, now let's go for kins and advisors. So kins and advisors are moving pretty similarly. The only difference is the direction. Okay, yeah, sorry, I just forgot to quickly walk through the pawns code as well. So we loop over the directions for pawn offsets. So here we're using the length of pawn move offsets directions, so just 3 moves, either upwards or downwards and left and right, so always 3 directions. Then to get the target square, we're adding the pawn square offsets indexed by the current side, because up and down direction are different depending on side, and then adding the direction again, like either up or sidewards in case if we are crossing the river. Then we're getting the target piece to distinguish between captures. Then we need to make sure the pawn is not, the target piece is not off board, so it still relies on a board. Then we push in the move, adding the source square is target square, board source square is the source piece, and target piece has already been distinguished here. It has already been initialized here. Okay, and then the trick to actually non-generating moves left and right pushes for pawn. So another zoning condition. So we're indexing the board zones. This one by the side. So for whites is this array, and within that array, source square. So let's say pawn on e4. So we have this pawn, so this source square, and it equals to 1, which means that we are on our territory. So we just break out of this loop, and we only deal with the first direction within the pawn move offset directions. So the first one, pawn move offsets either up or down. So we deal with this, and then if the pawn is on our side of the board, we no longer go in here or here, respectively. But if we have crossed the river, so if we cross the river, this would be 0 all the time. So in this case, condition equals to 1 is not true. Well, hold on a sec. Just to deal with a bug, I can make it like this. So it would be true, and 1 and 2 would be true in the both cases. Yeah, I think this is the way, as Mandalorian said. Okay, so let's update this stuff, and this should be. Oh, sorry guys, just I didn't realize that when I was implementing this stuff initially. So let's get rid of the cannon for a while. Let's put the pawn on e4, save. Okay, e4, e5, that's it. Let's put it on e3, e3, e4. And now even if we put this on e2, it still should be generating only one move. This is impossible position, but still. Okay, so on our side of the river, pawns are only moving 1 step forwards. So yeah, I think this is a little bit more accurate implementation. So we stick to that. Now the kings and advisors. So first, let me demonstrate how this works, and then we'll quickly walk. Well, no, let's just quickly walk through the code and then demonstrate. So here we were distinguishing the type, so it would be equal to pawn. Again, like no matter which side we have. So if we have the side, the piece color equals to side to move. So either white or black pawn we get here. Okay, here we're coming here. This color block in case if the piece type is king or advisor, and the difference between them is only the matter of the direction. So kings moving orthogonally and advisors moving diagonally, 1 square in both cases. So we loop over in this case I use the orthogonal length. I could have also used diagonal length. Literally this is 4 always, because we only have 4 directions. Then we initialize the offset. So if we have a king, we use the orthogonals, which is the array here, orthogonals. If this array is used, initialized points to this element in case of if the piece type is king, and if the piece type is advisor, then the offset points to the first element of the diagonal. So literally kind of I'm just talking in the low level terms, but this doesn't matter. From the high level perspective, you can assume that offsets becomes equal to diagonals, or offsets become equal to orthogonals. Okay, so let's move further on. So we've defined the offsets, and once we've defined the offsets, we just add in the offsets indexed by the direction, so either up, down, left, right, or diagonal 1, 2, 3, 4. whatever of them, up left, up right, down left, down right, and initializing the target piece, whatever on the board target square is available, so this square, and then we need to make sure that board zones over current site to move, that the target square should always be equal to 2. So we can have our advisors and kins outside of this 9 squares ever. That would be just the illegal position. So let's say advisor stands here, so he can move here, but he can move here. He can move here because it's not within the palace. So only if the target square equals to 2 within the board zones for both bishops and kings, only in that case we can make those moves. Okay, and yeah, and then it's just pushing the moves and the logic of distinguishing between the captures and non-captures is literally the same. So now let's try to put king and then advisors and then both, probably just to see how the things work. So let's say board E0 would be equal to, well, by the way, yeah, I just also want to show you that it still works for black pieces. So let's try now black king. Let's put it on E9, save, and generate moves for black, just to give you an idea. So here is the black king. He can go to D9, E9, D9, F9, and go into E8 and not going off boards, obviously, because anyway, off board would not be equal to 2. That would be equal to the off board constant, which is 15. So it's not 2, so it's not going off board as well. That's a little trick how to done with that. Okay, so that's it. And now let's get back to the white pieces. So I just wanted to show you that it also works for black pieces. So E0, I want to have the red king, and let's put it not to E0 but to E1 to have all the 4 moves available orthogonally. So to D1, to F1, to E2, to E0. Now we're just trying to put something here. Let's say put a cannon on E2. A king would no longer be able to go there. So let's put a cannon on E2. So now the king is, oh, this is the black cannon. So yeah, black cannon would be captured. So black piece would be captured. Okay, but if this would be own color piece, so let's say rack cannon. In this case, it's just not going to be there, not going there, not going to capture. So only D1, F1, and E0. So that's the idea. And exactly the same stuff is done for advisors. So let's say E1 would be advisor, and let's say D2 would be rack cannon. Okay, so we have advisor going to F2 here, going to D0 here, going to F0 here, and not going to D2. Okay, but if there would be opponent's piece, okay, in that case he can also go to D2, but in this case it just captures. And if we just put, say, it to its initial position, then I'm sorry, D0 in this case, say, just to show you how not escaping the palace works. So from this position he can only go to E1, so can go here and can go off boards as well. So this is the palace, okay, only goes here. So I hope this is quite pretty clear regarding how kings and advisors are moving. So the next thing to consider would be the bishop. So let's grab the bishop code. It's pretty similar to king and advisor code. In some cases it could be probably could have be the single block, but I just want to distinguish for didactic purposes and for clarity. So if we have a bishop, in this case looping over the bishop mobile set directions, which are diagonals multiplied by 2, because bishop kind of goes in 2 squares, not in 1 square like advisor, but like in 2 squares diagonally. Initializing the target square, the same stuff. Initializing the target speed, the target piece and all the same stuff. So let's have a bishop on, yeah, and also he can't, yeah, so here we have the right condition for board zones, unlikely the pawns, yeah. So bishops can go on our side of the river, and it can enter the palace as well. Okay, so let's just now put a bishop. Let's say its initial square to c0, red bishop, save. Okay, we have c0 to a2 here and c0 to e2 here, and this is the palace already. So can go here, can go here. But let's say put it on a0, so it won't be going off board, so only to c2, and let's put it to say e4. Yeah, that's possible. So let's put it on e4. So we have going only to c2 and to g2, and not going here or here, because bishops in CNC can't cross the river. So the river is the delimiter in the center of the board, so can't really cross that. Okay, so I hope this is clear. And again, like, let's put something on c2. So let's say board c2 would be the black cannon. In this case, we just capture it. Okay, and if this would be the red cannon, then we're not going to be capturing it. So only going to g2, because here we have our own piece standing. So that's it regarding the cannons, the bishops. Now knights are a little bit more intriguing, but also nothing, no rocket science there basically. I really hope this would be also showing, also working correctly during the perf test. That would reveal that would be the moment of truth. So we take the piece of the knight type, loop over directions. So first, knight can be blocked if. So we do loop over the orthogonal direction. So let me just put a piece, put a knight somewhere. Okay, so we've just been a little bit distracted. So let's take a knight. So red knight on e4, and let's have a look. So here is the knight. So we have the moves being generated. So e5 to c5, c3, c5, c3. So it goes here, 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 and here. But if, let's say, the knight wants to go here, then he should go here first and then here. So if here we have a piece of either own color or opponent's color, that means that the knight is blocked, and knight can't really jump over this piece. So first we need to loop over the orthogonal directions and make sure that there is no piece blocking the knight. So that's the first thing to consider. That's what we do here. So for the so loop over the directions of an orthogonal length, so 4 up, down, left, right. Then we initialize in the target direction, so source plus whatever orthogonal. And now if we have an empty square board indexed by this target direction, so whatever of 4 orthogonals, orthogonal directions, only in that case we now loop over the knight offsets. So let's go to knight move offsets to give you an idea. So knight move offsets. So let's say we have knight offsets that are mapped to the orthogonal direction. So let's say we are going so let's say orthogonal, hold on a sec, left. Yeah, so if we go in left orthogonally, then we have this left left up and left left down. So just to show you this, so let's say we are in the territory of the orthogonal left, then the knight offset for this direction would be left left up and left left down. So only this piece is empty, then we check for this square and for this square. And that's the way how to generate the moves for a knight. Okay, so Then exactly the same stuff, just initializing the target square. Already night offsets I used here, target piece, whatever is the board target square, and then we need to make sure that the target square is not going off board, and we just add in the move. We're not looking for off board for bishops because we use board zones instead, so that's a little bit different logic. And the same for kings and advisors, because these pieces are not are zone dependent, so there is a slightly different logic for them. Okay, so this is it. Now I just only want to demonstrate. So we have this, let's say this e4, c5, c3. So c5 and c3 can go here and here. And let's say we put a piece on d4. So let's put either red or black cannon on d4. d4, save. So now he can no longer go to either c5 or here. So let's well, actually this is, I hope you can see this, right? So still can go to g5, g3, still can go to d6, f6. So d6, f6, still can go to d2, f2, but no longer go into c5 and to c5 and c3 because knight is because this cannon blocks the knight. And no matter that this cannon is of its own color, if it's of the opponent's color, so if this is a black cannon, doesn't matter, still the knight is blocked and we're no longer going there. So no matter of what color of the blocking piece. So this is regarding the knight moves, and the final moves to generate the most complicated is rook and cannons. So, okay, just hold on a sec. Just need to make sure that indentations are match there, that the indentations do match. Okay, rooks and cannons, save, and let's make sure everything still works. Okay, so yeah, now we need to, well, okay, let's try to walk through the code. Well, this might seem a little bit complicated because the way how Canons captures is a bit tricky, but okay, I just try to explain this stuff. So we need to make sure that the piece is either rook or a cannon. Then we loop over the orthogonal directions because both pieces, rooks and cannons, are moving only orthogonally. Defining the initial target squares, so source square plus whatever is at orthogonals indexed by the direction. And we have this jump over counter. This counter is used to calculate squares, to calculate pieces after the initial blocking piece that initially blocks the slider. So I will demonstrate this when we would be testing this. First, just trying to describe things. So now we iterate over the orthogonal ray until we hit the edge of the board. We are defining the target piece here, so whatever is the new target square is available. And again, like to make this loop running, when we done all the logic at the very end of the loop, we just making target square plus equals orthogonal direction, so literally taking next, 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 so here, next, 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 and so on. Now, if jump over is equal to 1, this means that slider piece, no matter whether this was a cannon or a rook, didn't yet get blocked by whatever piece, either a friend or foe. So now we want to add all the rook moves. So if piece type is equal to rook and piece color is equal to the color opposite of this current side to move, in this case we add in all the rook moves, both quiet moves and captures. So for rook, all the moves are being added within the within this line. Now for cannons, this is getting a little bit more complicated. So we have piece equals to cannon, and the target piece is empty. So we didn't yet face any blocker for sliding cannon, right? So if we only have an empty square, so jump over equals to 0, this means that the slider array wasn't yet being blocked by whatever piece. So here we push in the moves for these are the quiet moves for Canon. And now in order to get the capture moves for Canon, this is how it's done. So every time we're facing whatever piece on the array of this where slider operates, we just increment this jump over by 1. So when we hit the first blocking piece, jump over would be equal to 1, but that's the exact piece that can be captured by the cannon, so we need to jump over that. That's hence the name jump over, and only the next one would be the one we can capture. So the next we have the next one after the first piece to block the slider's array, that would be exactly the second piece, so we can only capture the second piece. And this is the reason why we want to make sure that actually only when jump over is equal to 2 we can add the capture move for a cannon. But also we need to make sure that the piece type is cannon, because rook also comes to this loop, and we need to make sure that the color of the piece, the color of the target piece is opponent's piece, so we can capture our own piece with the cannon. So like we were matching the opponent's color for rooks, the same obviously is done for cannons. So that's it. Now let me demonstrate you this, so I hope it gets a little bit more clear after that. So let's put a cannon on e4. So e4 red. Now let's start with a rook. Save, and first get rid of this. So on otherwise empty board we have all the directions. Well, they're not shown like it was as in the e-square attack function, but still. So e4 goes to d4, c4, b4, a4. This line goes to f4, g4, h4, i4 here, and literally to all the places it can go. But now let's try to block this rook. So let's say we have e3 would it be equal to, yeah, let's block by the cannons, this is fine. And also let's say e board e5 would it be blocked by, I just used cannons because that's my favorite piece. No particular reason for that. My favorite piece in CNC, so cannon here. And also let's block left and right, so let's say board b4 is equal to black cannon, and also board let's say ed, let's say f4 is blocked by the black cannon. It's impossible, completely fair reposition, but anyway. So here's what we have. So we have the moves d4 to e4, d4 to c4, no, e4 to d4 to c4, and captures on b4. Also captures on f4, captures on e5 here, and captures on e3. Now let's make e5 and e3 to be friendly pieces. In that case, no captures would happen. So let's say we have red. Let's make king just to not to generate moves for that, to make sure not polluting the move list. And e3 and e5. I know this is impossible, but just the matter of blocking. So now we go e4 to d4 here, e4 to c4, e4 to b4, capturing, also capturing on f4. E3 to e2. Well, it's impossible move, but yeah, because yeah, let's make it e3. Let's make it black red pawn, just to not pollute in the move list. So kings are actually only to land on the within the palace, but it doesn't assume, the implementation doesn't assume the king can be outside the palace, because that's the legal position. So that was the reason for that move occurring. So now we have d4 c4, d4 c4, and b4 captures. Okay, and also not also capturing on F4, but not capturing here on E5 and not capturing on E3 because friendly pieces are there. So I hope that's quite pretty clear. And now let's put the rook. Let's put it on D4. Let's put the cannon. Save, and also these guys would be also say D and D like this. So just not to produce lots of moves. So you see, like the cannon is blocked upwards, so it's not going there, but it only can go here, C4 and E4. So he can capture, no matter a friend or foe. He just can't capture. He can capture only if jumps. So these squares are attacked by the cannon, but as far as there is no piece, he can't move there. So that's the idea. So yeah, that's how it works. And now I just want to put a couple of pieces here. So that would be G4 and H4. So let's put some on G4. So board G4 equals to, let's say black cannon. That's fine. Yeah, black cannon. And also board H4 equals to black cannon, but it would only capture the first. Sorry. Oh, what have I done? Board. Okay. So D4 captures on G4. So it skips this one and captures this one. Captures on G4, but it's no longer going here because we drop of the loop. Not drop of the loop because we just pushing the moves only in case if jump over is equal to 2. And then we break, and then we do break out of the loop. So we just break over, we break from this loop over the attack ray. Okay, and let's say we just take away this one from G4 and put it to H4. Let's just, I mean I4. So here we capture on H4, and let's say we just even put one on I4. Obviously we're not going to be able to capture that. That's illegal, so only captures on H4. And if on H4, say we make it some red piece, so let's say red king, save, then still we're not capturing on I4 because this piece is just is friendly, so we can't capture our own piece, and no matter what is there. So that's kind of how it works. Only D4 to C4 and to E4. Only the quiet moves are generated for cannon. If I just get rid of, let's say, put this one D5 to, let's say, D7, D5, D7. Okay, now we also have extra moves, so D4 goes to D5 and goes to D6 until it hits the own piece. So that's a legal move, so only these two moves. So this is it regarding the mode generation for cannons. So one of the most tricky pieces in CNC, one of my favorite pieces. Yeah, I just really love all the tactics arising from using cannon during the game of CNC, especially the opening variations, putting the knights in between the cannons, which makes cannons supporting each other, and that's a fantastic structure to work and to play with during the game of CNC. Okay guys, so I think this is it from my side regarding the mode generator. Well, I really hope I didn't miss anything. If I did miss anything, then definitely we will go back and make some fixes, some debugging, but in theory this should be working. Yeah, and one last task before we begin, before we end up this video. So I have a mode generator for CNC, which is derived from the chess.js. Also, we have this called CNC.js, which is derived from the popular JavaScript chess library chess.js. So it's a very similar structure, and it has a perf tester. Unfortunately, only for the starting position, well, I mean the values are available only for starting position, those I found. But I hope we can rely on these values. And we have 44 moves per depth 1, but actually to get this 44, this means like only make moves for the white, or sorry, for red. So only 44 moves is available within the starting position. So now we will generate the moves for all the position for the starting position, and manually count the moves to make sure there are exactly 44 moves. Because we don't have a prim move list, because we don't have a move list, hence we don't have a counter, and it's just easier once counted for manually, and then when we would be pushing the moves to the move list, into the move list, we also would be keeping track of the move count as well. So now I just want to initialize the standard FEN here, and like this, save, and here are all the moves for the starting position. So we already see this B2 to B9 capture. So here is B2 to B9. So in initial position, Canon can capture opponent's cannon. Okay. Also H2 to H9. So also in initial move, this cannon can capture this knight. And let's count the moves. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 40. Yeah, I just missed. There are 41, I swear. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 14, 15, 16, 17, 18, 19, 20, 21, 22, 3, 4, 5, 6, 7, 8, 9, 30, 31, 2, 3, 4, 5, 6, 7, 8, 9, 40, 41, 42, 43, 44. Exactly 44 moves as we have for the initial position. Now, if I just swap the side, this also should be given the same result. So if you just swap the side in the initial position, well, I think this should be the same, H7 to H0, B7 to B0, B7 to B0, H7 to here. So this should be 44 as well. I didn't count this one, so I'm sorry, I just really want to make this. So okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, 40, 41, 2, 3, 4, which seems to be absolutely correct. Now just to have a look at the moves being generated, so not all of them, just a few. So A3 goes to A4, so pawn push. Same for C3, E3, G3, I3, so the pawn push is here. And then starting from Canons, so B2 goes to A2, C2, D2, A2, C2, D2, E2, F2, G2, then goes to B3 and to B4, B3, B4, then should be B5, B6 and B1, B4, B5, B6, captures on B9, then goes to B1 and so on and so on. So that's how it works. So obviously it's not a way of testing the move generator, and we would be doing the perf test just to calculate the number of traversed node during the brute traversal, like brute force traversal of all the possible available moves there, and we will need to match this number, well, for starting position. So this is only perf depth 5, because perf depth 6 for this particular implementation of CNCJS library, it goes damn so slow. I don't know how long does it take, because probably it's a little bit too slow. But probably I would compose a couple positions and try to test them within this existing mode generator and try to match the numbers. I hope we can rely on this CNC.js move generator so to make sure it's kind of working properly. And well, I think the rules are not that complicated. So I was talking to guys who has implemented CNC engines already, and they said that even only using the starting position is literally enough for perf testing. I just want to try some custom positions to make sure that the e-square attack function is working and not letting the key being exposed into a check, and in that case we'll be almost 100% sure that the move generator is bug free. But before that we'll need to implement some more functions, so we'll need to, the next video probably we would be going for encoding moves, encoding and decoding moves. So we will be storing the source square, target square, probably source and target pieces as well as the capture flag within the single integer using the bitwise operations, and then would be having the functions to extract respectively from square to square pieces and the flag. Because having those, well, you might wonder that having the source piece and target piece is not really needed, but when it comes later to GUI, it always, sometimes it's very handy, and for generating PGN is also being very handy to have the pieces, the captured piece and piece that has moved being associated with the current move. When the moves are stored into the move stack, we just retrieve the data from the move stack. Then we loop over the moves, over the elements within the move stack, just taking the move, and from that move we can already extract not only the squares but also the pieces as well. So that's kind of it. Yeah, I think that's it. So this is from my side, guys. I really hope you enjoyed the video. This was the most probably complicated, time-consuming function to write, and this is one of the most core essential functions. So I hope this would be working properly. We'll see that. So this is it from my side. Thanks for watching until the next time, and take care.